In this example of arithmetic sequences in series, again, we're going to use this common rule for arithmetic sequences because we're told that this is an arithmetic sequence. But we have another little twist this time. In this equation or formula that we have, we typically want to start out and find, or we know, the first term. In this case, we don't. We only know the 9th term and the 14th term. But the process is basically still the same as far as we want to find the 6th term. So I'm going to do this in steps. So again, the first step, or step 1, is going to be to find the common difference. And that's one of the keys to this. So find the common difference. The only thing is, instead of using a sub 1, which we don't know, we're going to use a sub 9. And then for our a sub n, we're going to use a sub 14 in its place. So when we do that, that's going to change our formula or our equation and make it look like this. It's going to be a sub 14 is going to equal a sub 9 plus, and where we have an n, remember the n was with this term, and in this case it's going to be 14, so it's going to be 14 minus, and this 1 is always associated with this first term, but we don't know the first term. We're using the 9th term. So it's going to be 14 minus 9 times our common difference, d. So now it's just a matter of substituting in the values. We're going to substitute in 120 for a sub 9, and we're going to substitute in 195 for a sub 14. So let's do that. So we're going to have 195 is equal to 120 plus 14 minus 9 times the common difference, d. Now it's a matter of evaluating this or solving this for d, because remember our first step, we've got to find the common difference. So in order to solve this, the first thing we want to do is we want to simplify the 14 minus 9. So we're going to have 195 is equal to 120 plus 14 minus 9 is going to be 5 times d. So now we want to solve this for d. So we got to get rid of the 120. So subtract 120 from both sides. So when I do that, the 120 zeroes out on this side. So if I go over here and subtract, I got 5 minus 0 is going to give me 5. 9 minus 2 is going to give me 7. And that's going to be equal to 5d. Now, in order to solve that for d, we're going to divide 5 into 75. So 5 will go into 7 one time. And then that leaves me 2 left over. 5 will go into 25 5 times. So d is equal to 15. All right, so we found our common difference of 15. So we've got that part of it done. So now let's go to step 2. We need to find a sub 1, our first term, in order to be able to find the 6th term. So we're going to go back and use what we know, and we could pick either the 9th term or the 14th term, which is what we knew. And let's just use the 9th term. So we could do it this way. We'll use our regular formula, a sub n is equal to a sub 1 plus n minus 1 times our common difference, d. All right, in this case, we're going to let n equal 9. We'll use our 9th term because we know what it is. And our 9th term, if you go back, was 120. So a sub 9 is equal to 120. And we're going to use this information to help us find a sub 1. So a sub 9 is going to be equal to the first term, a sub 1, plus, notice if I'm using 9, then my n is going to be equal to 9 minus 1. And my common difference we found a minute ago was 15. I'll go ahead and substitute that in. Times my common difference of 15. The only other substitution now I need to make is I know what a sub 9 is. I'm going to substitute that in, and then we'll solve it and find the first term. So a sub 9 was 120. So I'm going to substitute in 120 is equal to a sub 1, which is what we're trying to find. We don't know what it is. Plus 9 minus 1 times 15. So let's simplify this now. 120 is equal to the first term, a sub 1, plus 9 minus 1 is going to give me 8 times 15. Let's multiply that out. 15 times 8. 5 times 8 is 40. Carry the 4. 8 times 1 is 8. Plus 4 is 12. So it's going to be 120. So I've got 120 is equal to a sub 1 plus 120. Now to solve that, I got to get rid of the 120. So I subtract 120 from both sides. So that means a sub 1 is going to equal 120 minus 120 is 0. So my first term in the sequence is going to be 0. So that's good enough for step 2. Now let's go on to step 3 and get to the heart of the problem. Step 3, we want to find a sub 6. I think that's right. That's what we're trying to find, the 6th term. Yep, the 6th term is what it asks us to find. So now let's use the information that we know. We know that a sub 1 is equal to 0. We know that the common difference, D, is equal to 15. And we know that N is equal to 6 because that's the term we're trying to find. So we go back to our common formula, which was a sub N is equal to a sub 1 plus N minus 1 times D. And now we just substitute in everything that we know. So we know that N is going to be equal to 6, so a sub 6, the 6th term, which we're trying to find, is going to be equal to the first term plus N, in this case, which is 6, minus 1 times our common difference, which is 15. So now let's go ahead and do one more substitution. We know what a sub 1 is. We found it previously. It was 0, so our 6th term, a sub 6, is going to be equal to 0 plus 6 minus 1 times 15. So the 6th term, a sub 6, is going to equal to 0 plus 6 minus 1 is going to give me 5 times 15. So that's going to be 0 plus 5 times 15 is going to be 75. So a sub 6 is going to be equal to 0 plus 75. So the 6th term of the sequence is equal to 75.